Simplifying a trigonometric expression is mostly an exercise in knowing which formulas to use, at what time, and a little bit of algebra. I notice here that we have a fraction in our denominator, and in order to simplify this, I think it'd be easiest to write the fraction in the denominator as instead multiplied by the reciprocal. So what we'll have instead is secant theta minus cosecant theta times sine of 2 theta divided by sine theta minus cosine theta. Notice it's just this over here. The reciprocal of that is right here. Now, just to make sure this secant theta minus cosecant theta is multiplied to this entire fraction, I'll put it all over 1. Next, we can simplify this quite a bit more by writing everything in terms of sine and cosine. I notice we have a sine of 2 theta instead of just a sine of theta, which we have a formula for. And we have formulas for secant theta and cosecant theta in terms of sine and cosine. Secant theta can be written as 1 over cosine theta. And cosecant theta can be written as 1 over sine of theta. Sine of 2 theta can be written as 2 sine theta cosine theta, and sine minus cosine will stay the same. Next, cosine and sine in these numerators right here, these two fractions could be combined. We'd have to find some common denominators first, though. The common denominator between these two, considering they're so different, would just be sine theta cosine theta. The denominators multiplied. That means this first fraction needs a sine of theta, and the second fraction needs a cosine of theta. They both have a denominator of sine theta cosine theta, so we can combine them. The second fraction I will leave the same. 2 sine theta cosine theta divided by sine theta minus cosine theta. I notice here that we have a lot of terms that can cancel out. So I have sine theta and sine theta in the numerator and denominator there. Cosine theta, same here. And then I have the entire term sine theta minus cosine theta here and here. Because of that subtraction, the term needs to match exactly. And that is sine minus cosine. Notice that all that's left is 2, which seems a bit strange. We're expecting 2 sine theta or something to that degree. But sometimes you can't have a constant. What this means is that if I plug in any theta that doesn't give me, a problem, into this expression right here, I should get 2.